Hello friends, today we will solve the numericals of your electrostatics chapter. Okay, and this one is related to your Coulomb's law. So you write the question by pausing the video. Two equal point charges q equal to plus root 2 microcoulomb are placed at each of the two opposite corners of a square, and equal point charges small q at each of the other two corners. What must be the value of small q so that the resultant force on capital Q is 0? Okay, so let us draw this one. So now let us place the charges. Okay, this is square of side A in all the sides. Okay, clear? So let us place the charge. Let us place Q here and Q here, and at this point let us place mine Q and Q. Okay, because it has already told in the question two equal point charges q are placed at each of the two opposite corners. See, two opposite corners. Similarly for small q charges, and remember always, if these two are plus, this has to be minus, this two has to be minus, because only then they can be able to stay in a square. Okay, if you place the similar charges, what will happen? They will repel, so they cannot stay at their original place. Okay, so something is there, some force is there, because of that they are bound to stay at the four corners of the square. Okay, and we need to find the value. What must be the value of small q so that the resultant force on q is 0? Either this q or this q is 0. Okay, we need to find that. Okay, so how it can be possible? If the force applied by this one, this q to this q, is equal to force applied by these both charges to this q, then only we can say it will stay at equilibrium. Again, if the force applied by this q charge to this q charge is equal to the force applied by these both charges to this, then only it will stay at equilibrium. Okay, so let us draw a diagonal. Okay, so this q, suppose this is plus or minus, what will happen? It will repel, so that the direction is like this. This is one force, let us take it as F. This force who is applying? This q is applying a force on this one, so the direction is like this. Okay, now this q will also apply a force on this one. What should be the case? These are opposite. This is a case of attraction, so the direction is like this. This is F1. This one is also apply a force, yes or no? So what is this force? F2, as both these are opposite charges, so there is a case of attraction, so the arrow mark is like this. Clear? Okay, so where should be the resultant force? The resultant force is in this direction, right? So we have to show that this force F12, 1 and 2, F12, right? This F12 should be equal and opposite to that of this F, then only this will stay at equilibrium. You know it very well. If a force will be applied this side, if a force will be applied by this side, what will happen? This charge is bound to stay at its original position because all the forces being applied at the opposite direction, right? So let us find out this F first. What is this F? This F is equal to Coulomb's force. What is the formula? Charge into charge, Q into Q divided by 4 pi epsilon naught R square. And what is the R? What is this distance? If this is A and this is A, what is the diagonal? The diagonal is root 2A. You know the formula. Okay. Perpendicular base. This is the hypotenuse. So your formula is what? Root 2A. Right? So this is root 2A. Clear? R square. Okay, so root 2A whole square. So this is your Q square by 4 pi epsilon naught. Root 2 square is what? 2A square. Clear? So now find out this F1 and F2. Both are same because these are equal charges. Okay, so F1 equal to F2, Q into Q divided by 4 pi epsilon naught. What is the distance? A, R square. Okay, this distance is what? R. And what is this value? A. So A square, right? Okay, so therefore what is my F12 resultant? You have to draw like this. This is the vector technique, you know it very well. Okay, so how can you find out the resultant? Formula is root over of F1 square plus F2 square plus 2 F1 F2 cos, as this is a square. Okay, you are drawing like this. Okay, and we are finding out the resultant. What should be its angle? Okay, its angle is how much between F1 and F2? 90 degree, right? What is cos 90 degree? 0. So this part is 0, only this part is remaining. So what is root over of this square plus this square? We'll get the answer as 1 by 4 pi epsilon naught root 2 Q into Q by A square, right? How I got this equation, this answer? Because F1 square plus F2 square is how much? These two forces are same. You will take 2F square, that is root over of 2F square. So similarly this will be F square's root over is what? Cancelled, only F root 2, right? So root 2 is there, F is there. So I have multiplied root 2 only with F. What is F? F equal to F1 equal to F2 equal to how much? This much, Q into Q by 4 pi epsilon to x square. So Q into Q 4 pi epsilon to x square multiplied with root 2. Okay, so as we have found out your F12 and F, okay, F12 and F, now we will what? Equate. Okay, so as we know that your F is a positive force, because already in the question it is being given your capital Q is a plus quantity, so small q's has to be negative. So what we will write? F is equal to minus of F12, because F12 force is applied by whom and whom? They are applied by small q's, so minus. So let us now solve it. So this will become q square by 2a square is equal to minus root 2 q by a square. What I have done, your 1 by 4 pi epsilon naught and 1 by 4 pi epsilon naught, this side I have cancelled, right? So at last, what you need in the question, it is asked the value of q, small q. So small q equal to, if you solve, you will get the answer minus q 2 root 2. Okay, now let us place the values. Minus q value is given how much? Root 2 microcoulomb whole divided by 2 root 2, right? A's value is how? This one is how much? 2 root 2, right? So your answer you will get minus 0.5 microcoulomb. Thank you.